Okay, there's a question. What is this? How do we find the centroid of a non-right angle triangle? Yeah, I think if you have your textbook, uh, is it at the back? You have the table where it shows uh, the position of the centroid of, I think that is not a right angle triangle. So it is 1/3 of the height, yeah. Meaning that meaning that considering the base is the flat one is a base, right? And then it's 1/3 of the height. So you can determine that one. But if you want to have both x and y axis, normally the easiest way is just split the triangle into two right angle triangle. That's the easiest way, right? If you have whatever shape of triangle, you just divide into right angle triangle. So that's easiest. It will be multiple triangles, of course. Um, all right. So I'll just go through this one. I'm not sure how many of you, I haven't marked this one, right? So hopefully everyone is doing okay for this one. It's not that difficult. Um, so in the previous quiz, which is quiz number, what is this? Quiz number 10. The diagram is given as such, and the question specify that you need to actually select either or, vertical or horizontal, because some may find one of those easier. All right, so this is just a brief explanation for anyone who needs some explanation. So basically, what we should know from the very beginning is that when we need to calculate for centroid, what is this? Okay, what is the question? Okay, locate the centroid of the area, right? So either be it vertical or horizontal. So the equation is the same. It will be x bar itu integration of x with dA over integration of dA, and similarly y bar equal to integration of y with dA over integration of dA. So what will be different in this case is how you divide the area, right? So if we take the first one first, if we take the vertical element, that would mean that essentially we divide into this type of elements. Hence, the first element will be here, the last element will be here, right? So one sample element will be this rectangular, right? So from there, you know straight away that the limit will be from 0 to 4, because that's the integration from the first element to the last element, right? By now, hopefully you understand already that the limit of the integration does not have any relation whether you calculate for x or y. It is about how you divide your area, right? Regardless of the equation. So that's the first thing. And then, of course, when you want to do the integration, you need dA, or differential area of each element. So from here, this is for dx, and you have to know what is this height. And considering that this is a point on the curve with the coordinate of x and y, a generic coordinate, so you know that this height will be y based on that coordinate, right? So hence you get that one. So you'll get dA equal to y dx, right? This y is not this y is okay. Why is this becomes y? Because of exactly this, right? So if your area is not the height is not y, then you should not write y here. You should write whatever it is that is the height. All right, so that is dA. And then you also need to compute for the x wave, y wave here, which is the coordinate of the centroid of the element itself, right? X wave, Y wave there. So from here, you will know that because X is this one, okay, X is this one, right? This is X coordinate, right? So X wave is exactly X. So you know X wave is X, while Y wave is Y over 2, right? Because the full height is Y, and then this is halfway, so it should be Y over 2. So based on that, you can just plug in into your equation, right? So from here, you have X bar equal to integration, then you have the limit from 0 to 4, 0 to 4, and then X wave is X. So X and then Y dx, Y dx over integration from 0 to 4 y dx. Obviously, you have to convert this y into x by using the equation here, right? So you can just plug in y equal to 1 over 2x into here, and then you get your equation that you can integrate until the end. Similarly with this one, for y bar, then integration, of course, limit is the same, 0 to 4, 0 to 4 here, and then y wave is y over 2, so y over 2, and then dA here is y dx over integration of 0 to 4 y dx. Similarly, of course, simplify this first and then substitute y equal to half over x, half x inside there, and then you get your equation that you need to integrate, and the rest is mathematical calculation where you do integration. All right, so this is the story when you do use the vertical element, which is the easier one for this area here, right? So if you actually choose to do horizontal element, so the element, or basically what you do is you chop the area, okay, like this, right? So basically one sample area will be a horizontal element like this, and the first the first element is here, the last element is here, right? So your limit is from 0 until 2, right? So then the area itself, the element itself, so this will be dy, and here what is the length? So here is where you have to know this distance here, right? So taking this point as the generic x y coordinate, so you understand that this length is x and this whole length is 4 here, right? So which means this length of this is 4 minus x. Yeah, so it's just logical calculation there as long as you understand what's going on. So with that, we will get dA equal to, okay, might as well write somewhere else. So oh, okay, too much. Okay, 4 minus x. So dA equal to 4 minus x dy. Okay, from here you might see that the equation might be a bit more elaborated compared to using the previous element, right? When you want to integrate later on. So that's one, and then what about x wave, one wave? So if you use this color here, so this is the centroid where you have x wave, y wave, right? So the easy one first, y wave. So y wave is just y, because this is y coordinate, and this is y wave, so it's the same thing. What about x wave, right? So here, so this is where some student, I noticed, they get confused, because you have to understand that the coordinate, this x wave, y wave is a coordinate, it's not a length, it's a coordinate. So the coordinate have to consider this length here, right? Oops, this length here, right? Meaning there's two way of it, looking at it. One way, some student prefer to see that this height length here is half of this length, right? So half of that, so meaning that but if you do this, you have to add with this length, right? So meaning that you have x plus half of the two, this one, right? So 4 minus 2, sorry, 4 minus x, 4 minus x over 2, right? So that's one way to look at it. Basically this x plus half of this length 4 minus x. That's one way to look at it. For me, easier way is just this point here is the average between this. Should I use different color? Um, this point here is just the average between the 2 point here because it's at the middle, right? So the average between 4 and x. So to calculate average, you just add 4 plus x over 2, right? That's the average. Of course, if you solve this one, it will be exactly the same, 4 plus x over 2. So it's the same regardless of whichever way you understand, as long as you understand the correct thing. All right, so then you have this expression, x wave equal to this, right? So how to calculate further? Then the implication, of course, for example, okay, let's start with example for x bar equal to integration of course, the limit will be from 0 to 2, 0 to 2, and then you have x wave, right? X wave is this thing here, right? So 4 plus x over 2, and then dA. Where's my expression of dA? Oh, here. So then 4 minus x dy over integration of 0 to 4 minus x dy. So as you can see, the equation is just a little bit more complex than before. You can simplify this to if I take half outside, so it will become 4 plus x, 4 minus x, so it become 16 minus x square dy, right? And then increase 0 to 4 minus x dy. And then you can continue on further where you have to replace this x in terms of y. Right, from here you know x equal to 2y. So you just plug in there, and then after that you are ready to integrate, and the answer should be the same for both elements. The rest is mathematical, so I think you know how to do integration. Otherwise, I hope you also have watched the video on integration to revise on integration if you need to. So that is just to explain the different solution that you have to go through uh, based on different choice of element. Now, for the final exam, it can be many possibilities. One is the question just say find the centroid. So you are free to use any element, but you have to state clearly whether you use horizontal or vertical. That's one possibility. And previous exam tend to be like that. But some exam, if I personally make the question, normally I like to specify like this. For example, I purposely want you to use horizontal element here, even though vertical is easier, but I just want to test you whether you know how to do all of this using horizontal. So I can specifically ask, find using horizontal. So you have to know how to do this, even though it's more difficult a bit compared to vertical, right? So that's another possibility. Another possibility is you have to calculate both. In previous exams, sometimes that also is the case. It actually depends on how much marks is allocated for that question. So yeah, so those are all the possibilities. So you have to understand how to use both, because the question can ask for both or can ask for the more difficult one, etc. But if the question did not specify anything, just go for the easier one. The answer will be still the same, and the calculation will be much shorter. All right, so those are the things that I think is crucial for you to understand. And next is, I think, just know how to integrate properly, right? Do not be in a rush that you actually integrate x with dy, which is wrong. You have to check, oh, this is dy, so I have to change x into y first, vice versa, right? Sometimes students in a rush maybe they didn't realize that, then they straight away integrate. For example, here the integrate becomes 4y plus whatever, which is wrong, right? Because you have to convert this into into y first. Yep, I think that's it for this previous quiz. I'm not sure whether you have any question, so I'll stop sharing this one first. Anyway, So for those who listen or go through this explanation, hopefully it is clear. Of course, any other question, feel free to ask. Otherwise, okay, what is this? Yeah. Okay, so I'll leave it back to you whether you have still something else to do, some or finish, etc. We already have finished chapter 9, right? So next class will be chapter 10. We will go into moment of inertia, and I think then next quiz will be about moment of inertia, where you have to deal with integration as well. Yep. All right.
Sir,
Yes.
I want to ask question about attention quiz number 1.
Okay, wait a minute. This is mana pula file ni? Okay, this is class slide, right? For 9.2, right?
Yeah.
Okay, so the attention quiz, yeah. Okay, yang number 2, the box one, the
Number 1.
number 1, okay.
How to find the centroid?
How to find,
how to divide the shapes?
how to divide the shape. Actually, there are several ways to divide this, but the question is what is the minimum number? So the minimum number is okay. You do not okay, when you ask the question, you do not have any idea how to divide, or you do not know what is the least number. I mean, what's the context?
No, both. No.
Okay, okay. Let me see. In term of okay. I think after you have done some exercises, you might this might be more, how to say, you can automatically see this thing. Oops, mana dia? Now, one way, because one way to actually divide the area is actually by subtracting. Yeah. So meaning that if we take oops, meaning the whole thing there is just this big rectangular minus this triangle up here minus this, is it semicircle here? Yeah, this shape here. Then it will become this area. So that's the easiest one, I think. You take the whole big thing minus that triangle minus that semicircle, I think. So we just this minus this minus this.
Oh, okay.
Because if you want to add whatever then that would be, you have to integrate as I'm not sure what you can do. So easiest one is just take the whole thing and minus like this.
Okay.
Okay. Yes.
For that question, right? If we divide to 3, then how are we going to find the triangle, because it's a non-right angle triangle?
How do you find what?
The area of the triangle. I mean, not the area, the centroid for the triangle, because it's divided into 2.
Okay. Because okay, when something is symmetric, it is all automatically at the middle, right?
Yeah.
Meaning something like this is symmetric. Of course, this is symmetric both ways, so that's why it's the middle. So when it's symmetric, it's obviously on this line. So the only question is this, because this is obviously, because it's 2 and 2, right? So it's on that line. on that symmetric line.
I see.
So that doesn't even need to be calculated. You can just see it is symmetric, because that's one of the concept that we cover, right? I think in this slide, because when something is symmetric, it's the centroid will always be on that symmetric line. Is it clear?
Yes, and then the wait, how do you say it? Like the x is on the symmetry line, and the y will still be in the symmetry line, right?
For the triangle,
Yes, correct.
why doesn't have any symmetry, right? Because when you have something like this, it is symmetric here, right? Meaning that this it's mirror, right? But you
Yeah.
do not have any symmetry here. Here is more on 1/3, 2/3, 1/3, 2/3.
Oh, for the height is 1/3. I see. Okay,
Yeah.
but the base is symmetric.
It's symmetric right and left, meaning that you divide this. How to say? This mirror this one. You understand? Yeah. So when something mirror, it will be on that mirror axis, on that dividing mirror axis.
I see. Oh. I think I get it, doctor.
Okay.
Doctor, can you discuss the concept quiz? The answers for the concept quiz?
For this one? For this one?
Yeah, for the slides. Yeah.
Which one? Both?
Both of them. Yeah.
Okay. Based on the typical available centroid information, what is the minimum piece number? Okay. In this case, what is the minimum? I would say, for me, I would say 3, because it's just you divide here and you divide here. Can you see the screen? Is it too small?
That's not small, doctor. I can see it clearly.
You can see?
Yeah, I can see.
All right. So as I mentioned, it will be just divide here, so that we have a rectangular down here and then divide here, right? In this case, you have to divide because it is not symmetric. Because this
Understood.
length here and length here, so you have to divide. For the previous case, it's symmetric, so you don't need to divide because it's all you know already it's at the middle plane, so it become 3. In this case, this actually combine the concept of what is it? Center of gravity, right? Do you understand this concept question? Meaning that if you tilt up, meaning that this will tilt up that way, right? Meaning it will,
Yes.
it will tilt up that way. So what is the maximum angle that you can tilt, right? So, okay, well, maybe I'll have to.
My answer is 60, doctor.
Yeah, it will 60. Why do you answer 60?
I use the concept of right angle triangle. That's why.
Yeah, okay. The idea is basically
I mean, it's
when when G, okay, when point G is right above this, that is where the tipping point is, right? Because if G is here, then it will
yep.
produce moment clockwise. If G is here, it produce moment this way. So the maximum is 90 degrees. So if this is already given 30, so it should be 60 here. Yeah, that is correct.
Yeah, so that you'll be balanced. Like there's no moment at point A.
Yeah. That's the maximum point that it can go before it tips.
Understood, doctor. Thank you.
Okay, welcome.